So the other form of spread we're going to see a lot in this class is standard deviation. Standard deviation is a measure of how much our data varies from the mean. It actually gives us the average distance of our data points from the mean. So the calculation is super important here. One, just like with mean, we have two different variables that we use to define the standard deviation, depending on whether we have a statistic or a parameter. So as a reminder, I did not talk about this on the mean one. I got so excited about the summation notation, that sigma notation, that I forgot. But here we have S versus sigma. Just to tell you about the mean, since I blew past that for the mean, we had X bar and we had mu. We typically use Greek letters to refer to parameters versus just regular, what are those called? I don't know. Regular, normal letters that we're used to refer to statistics. Another thing to note is that when we did the calculation for X bar and mu, the calculations were identical. Add up all the values, divide by the total number. The only thing different was that our total number here we referred to as n, right? And our total number here we referred to as little n for the difference between the name of the population size and the sample size. But literally the exact same calculation. It was just semantics about whether we labeled it X bar or mu, depending on whether it came from a sample or a population. That is not the case with standard deviation. If you look at these calculations, they are actually different. We're dividing by the population size in the sigma, and we're dividing by the sample size minus 1 in the standard deviation for a statistic, an S. So big difference, and you'll note in every calculator they pop out both. We are only ever going to be getting S in this class. We're never going to calculate sigma. We don't use, we're doing statistics, so we're using samples to infer about populations. We don't have population data. So just wanted to make a note here. The population standard deviation does have a different formula, and it really matters when you go to your calculator that you grab the right one. There is a way to compute this by hand. It sucks. We're going to do it once just so you can really see and feel and understand what the heck the standard deviation is. The reason is I read a lot of questions about, well, what would happen if I changed this data value, if I removed this? And I think the best way to know is to really understand what the calculation is doing. So in order to do that gross calculation, which I'll write down again, it was this big ass square root summation. I'm not going to bother to write the n and the I equals 1. Xi minus x bar squared all over n minus 1. So we're going to take every value, figure out how far it differs from the mean, right? Those deviations. We're going to square them and we're going to add them up. The reason we want to square them is because we want to see how far away they are from average, and we want those to all be on the same scale. What I'm saying here is that plus 5 is the same thing as minus 5. So if we square them, we have that feeling there. So anyways, we're going to go through this in stages so we can actually see that happening. So I have a very silly example here from Harry Potter. So Harry Potter used to have, I don't know if they still do, a whole defense against the Harry Potter. Rate My Professors used to have a whole Harry Potter section where they actually had fake reviews for a lot of the Hogwarts professors. It's been a while. All right. So let's pretend that you looked on Rate My Professor and that all 3 of these Defense Against the Dark Arts teachers had a rating of 3 stars. And so you wanted to see whose class you wanted to take. And so you look, and here are the different individual scores for each of these professors. And this is when this spread, you can kind of see why it matters so much, because everyone's going to have a different opinion about which professor you'd want to take. Ignoring the fact that we know who these people are if we're Harry Potter nerds. But some people would choose Professor Lupin because they know they're going to get an average quality professor. They don't care that it's not going to be great. They're just happy to see, okay, chances are, I feel this is consistent, right? Versus some people might choose to go with, say, a Snape, where they're like, well, some people really love him, some people really hate him. At least now I know that one of these things is going to happen. I have the possibility of having a 5 professor. And you might see that same thing with Moody. Some people might choose Moody because while they like the idea of having somebody who can get to a 5, they like that nobody's rated him a 1. So it's I could be knocking it out of the park. He could be a 5, but worst case, he's still all right, right? So anyways, that's sort of why spread matters again. So we want to calculate our standard deviation. First thing we're going to do is figure out how far each of these things are from our average. And they've told us what our average is. X bar is equal to 3. If we calculate it, I promise they all average out to 3. So in this case, none of Lupin's reviews vary at all from that average because they're all exactly the same. Moody, on the other hand, 2 of his reviews are 1 below his average, 2 are exactly his average, and 1 is 2 above his average, right? And then for Snape, well, he's all over the place. People have rated him 1 above, 1 below, 2 above, 2 below. All right, so there's our deviations. Now, as we saw in our calculation, right, we want to do these things squared. So the next step would be to take all of these values and square them. Well, 0 squared is still just 0. And now you see those negatives are becoming positives, and the further things are from average, the more they're sort of being penalized. And we got that step done, right? So we've done the deviations, we've squared them. The next piece is to deal with that summation, number 4, add up the squared deviations. So for Lupin, I could add all those up and we get 0. Moody, we get 6. And Snape, we get 10. All right? So what we just found is this whole top piece, right? All we need to do is divide by 1 less than our sample size and take our square root. So I'm going to do both of those in one move. So our S is the square root of that summation divided by N is 5 right there, 5 reviews minus 1. So this is just going to be the square root of 0, which is 0. This is going to be the square root of 6 over 4. I've just simplified that 5 over 1, which there's no reason to do any simplifying or anything fancy pants in terms of math. This is 1.2247. And then our last one, 10 over 4. We've got 1.5811. So we can see how these measures of spread really work, especially well with the standard deviation. When there was 0 spread at all, everything was exactly the same. We saw 0. We started getting a little more spread, right? Now we're at 1.22. And then the one that was the most spread out, Professor Snape, he's got the highest spread of 1.5811. So anyways, that's how you calculate standard deviation. We're never, ever, 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 ever going to do this by hand again. If you're ever in a stats class where you're supposed to do this by hand, run the other way as fast as possible because technology should be doing this for you.